Now we want to consider a line through a given point parallel to some vector. That line is going to have an equation. To figure out what the equation of the line is, let's represent the point 4, 7, negative 2, a point on the line, and the vector, which would be 2i plus 4j minus 3k. And let's go ahead and put a little notation on that. That's our point. This is our vector. What do we mean by the line through this point parallel to this vector? Well, it should be pretty obvious. That's simply a line that passes through this point in the direction of this vector. Now, if we want to find the equation of that line, the equation of the line is simply an equation in x, y, z that relates the coordinates of this point to these parameters here. So I'm going to let x, y, z be some point out in space, and we might or might not consider this point to be on the line, but the condition for the point to be on the line is that x, y, z is on the line if and only if the vector from this point to this point is parallel to this vector. So, fairly obvious condition. Let's call this the vector. Well, what is this vector? It's x minus 4 I plus y minus 7 j plus y plus 2 k. So this vector has to be parallel to this vector. We can say x, y, z is on the line then if and only if the vector x minus 4i plus y minus 7j plus z plus 2k is parallel to this vector v. And that's 2i plus 4j minus 3k. Now, what do we mean by two vectors being parallel? We simply mean that one vector is a constant multiple of the other. So, x, y, z then turns out to be on the line if and only if there exists, now this is symbol for there exists, a constant which we'll call t, and we could call this constant c, q, aardvark, anything we want. But if there exists a constant that we're going to choose to call t, such that this vector is a multiple of this vector and t is the multiplier. So we're going to say x minus 4i plus y minus 7j plus z plus 2k is equal to t multiplied by this vector, 2i plus 4j minus 3k. Now, what does it mean for two vectors to be equal? It means that their I components are equal, their j components are equal, and their k components are equal. So, we're going to have this equality if there exists a t with the property that x minus 4 equals the I component here, which we easily see to be 2t. Also, y minus 7, the j component here, equals the j component here, which is 4t. And also, z plus 2 equals negative 3t. So now we have three equalities that constitute the condition that this point lies on this line. There are two things we can do with these four equations. One thing is we solve for x, we get x equals 4 plus 2t. And y equals 7 plus 4t, and z equals negative 2 minus 3t. In this form where we solve for x, y, and z, these are called parametric equations. If we substitute a variety of different t values into these three equations, using the same t value for all three equations before going on to another t value, we're going to get the x, y, z coordinates of a series of points on this line, and we'll see what that might mean geometrically in a minute. So these are called the parametric equations of the line. There's another set of equations called the symmetric equations, and we get that very easily from these three conditions, simply, or from the parametric equations, it doesn't matter, if we simply solve each equation for t and set the results equal to one another, and we'll see that in a minute.